Hello, I want us to make a summary of this topic, longitude and latitudes, and we start with some terminologies. So first we need to understand this topic deals with sphere and specifically the Earth, and we say that the Earth is always spherical in shape and the radius is always given as 6370. Mostly it ranges between 6370 and 6380. So in most of the question, you're going to get the radius as 6370. And when you're not given in exam, you always use 6370 as the radius of the Earth. Now let us look at some terminologies. We have what we call great circles and small circles in this topic. What are great circles? Great circles are lines which are drawn on a sphere such that they divide that sphere into two equal hemispheres. And small circles are also lines that when you draw them on a sphere, they form circles which they don't divide the sphere into two equal hemispheres. Then we have lines, the great circles. Most of them are going to pass from the north to south. And these lines that are passing from north to south are always called the meridians. Now we have a very important meridian which passes through Greenwich in London. We call it the Greenwich meridian. It is used as a reference for other meridians. When you want to get the position of other meridians on a sphere, we use the Greenwich meridian to get the position of the meridian. For example, if I have this one here, I'm assuming this is my Greenwich meridian. Let me do it well. Then I have another meridian like this, and I have another one like this one. So this is north and this one is south. And then this one can be my equator. I will talk about equator at some point. So if this one here, this is given 0 degrees, it is used as a reference for other meridians. Then if this is our equator, I'm assuming this is where that one is, the center of that equator. Then if this angle is 20 degrees, then we say this one here, this meridian is 20 degrees east of the Greenwich meridian. Then if this one here, if you measure this angle, and maybe you get this angle is 40 degrees, then it means we say that this meridian is 40 degrees west of the Greenwich meridian. And that's why we are saying that Greenwich meridian is used as a reference to get the position of other meridians on a sphere. The same applies to equator. Equator is the only great circle that is not passing from north to south, because it can also divide the sphere into two equal hemispheres, the northern hemisphere and the southern hemisphere. Now it is also used as a reference for other latitudes, the small circles that we drew. And remember, we have said that small circles, they can divide the sphere into two equal hemispheres. So we can have a small circle here like this, and we have another small circle here like this. So if this one, maybe it's, let's say it is 40 degrees from the equator, and this one here, let's say it is 30 degrees from the equator. When you measure the angle, and this is how you measure the angle. So I'm assuming if you measure this angle here is 30 degrees, and when you measure this angle here like this, then you realize this angle here is 40 degrees. Then we say this latitude here is 40 degrees south of the equator. And this angle here, if it is 30 from the equator, then we say this one is 30 degrees north of the equator. And therefore, the equator and the Greenwich meridian are very important in getting the position of latitudes and longitudes. Now, that is very important. Then we come to position of a point on the surface of the Earth. If you're told to give the position of a point on the surface of the Earth, we always state it using latitude and longitude. You start with latitude, then comma, then longitude angle. For example, if I have a point, for example, point A is here, and I'm told to give the position of A, I will state the latitude angle. That point is on 30 degrees north, that is the latitude angle. Then you state the longitude angle. It is on 20 degrees east. This one will be 20 degrees east. And that is how you give the position of a point on the Earth's surface. Then the next thing, it is the angle between 2 points. For example, if I have point B here, and I'm told to get the angle between A and B, they are on different sides of the Greenwich meridian. This one is on 20 degrees east. This one is 40 degrees west. So if they are on different sides of the Greenwich meridian, to get the angle between them, you add if they are on different sides of the Greenwich meridian. If they are on the same side of the Greenwich meridian, you minus. For example, if I was to have another meridian here, which is, let's say, 15 or 20 degrees west, and I'm told to get, this is C, to get the angle between B and C, I just minus the two angles, 40 minus 20, to get the angle between B and C. But for B and A, you add because they're on different sides of the Greenwich meridian. The same applies with the equator. When you have 2 points, for example, one is here, let's say this is D. When you have this point here and this point here, and you're told to get the angle between these 2 points, they are on the same longitude but different latitudes. To get the angle between them, you add. This will be 40 plus 30 to get the angle between them. But if they're on the same side of the equator, you subtract. Distance between 2 points along great circle. Along great circle. You can either get, we always get the distance either in kilometers, Roman 1, kilometers, or Roman 2, nautical miles. You can always be told. But it's very important to know, are you getting the distance on a great circle or on a small circle? If it is on a great circle and in kilometers, we use length of an arc. We say that distance will be equals to theta over 360 times 2 pi r. That is the formula. Theta is the angle between the 2 points, and radius is the r is the radius of the Earth. And we have said we always use 6370 unless stated otherwise. Then if you're told to get the distance along great circle in nautical miles, we say it is theta multiplied by 60 nautical miles. We always say that 1 degree always obtains 60 nautical miles. And therefore, what about theta? Theta is the angle between them. That's why the formula is theta multiplied by 60 nautical miles. So if you have been told to find the distance along great circle in nautical miles, you take theta times 60. Theta is the angle between those 2 points. Then lastly, distance along small circle. Distance between 2 points, this is B, along a small circle, So again, you can either be told to get the distance in nautical miles or in kilometers. The one in kilometers, consider this diagram here. So if you have our equator, this is our equator here, and we have this one here, like this. So this is our small circle, and this is a great circle. And what you're supposed to know that great circle, the radius of a great circle is equal to the radius of a sphere. And that's why in our first formula, it was very easy. Now for small circles, the radius are different. If this one is r, the radius of this circle cannot be equal to the radius of this circle. This one can be capital R. So we can draw a line, and this one is still R. So if this latitude is subtended by theta degrees, then alternating angles, if this angle is theta, then this angle will also be theta. So if I'm to extract that triangle like this, we're going to have, this is theta, and this is R, this is small r. Then using SOHCAHTOA, we see which one can relate this side and this side. When you're here, this is adjacent and this is hypotenuse. It is K. K is the one which relates. Hence, we're going to say cos theta is equals to adjacent, which is R, divided by hypotenuse, which is R. And therefore, to get small r, which is the radius of the latitude, will be equals to r cos theta. R cos theta, where theta is the latitude angle. This one here, it is the latitude angle. It is theta degrees north. That distance will be theta over 360 times 2 pi r. R is the radius of that small circle, or the radius of the latitude. So therefore, this formula can be written as distance is equals to theta over 360 times 2 pi r cos alpha. So this time around, we use something different because we have theta. Theta is the angle between them, and alpha will be the latitude angle. For example, if I'm given this kind of a question, if I'm given this one here, and I'm given this one is 60 degrees north, and you have a point here and you have another point here. If this one is maybe 20 degrees east and this one is 30 degrees west, and I'm told this is A and this is B, and I'm told to find the distance between these 2 points, I will say it will be distance will be theta. Theta is the angle between them. So just take 30 plus 20, which is 50, divided by 360 times 2 times 22 over 7 times r, which is 6370. That is the radius of the earth. Then cos alpha, we've said you take the latitude angle as your alpha, which will be 60. Then you see, if you do this one, you get the distance between those 2 points. Distance in now nautical miles. Distance in nautical miles. So what we do, we say distance in nautical miles given as theta times 60 times cos alpha. That is how we do it. So theta is the angle between them, and alpha is the latitude angle. And that is how you can summarize this topic.